Yep. Right. Okay, so good morning, everyone. I'm Jerry Tan from Latel Robotics. So welcome to this, I would say, like a short session of AI robotics workshop or introduction this morning. And thanks to Abu, first of all, to having organized and invited all the participants here today. So as we discussed just now, I think there are different profiles of the participants here. Some of you have already received the account for the Robot for All. I think about 5 of you, and then installed the Jupyter Sim. I hope that everything went well. And then some of you maybe just join this session for exposure to learn more about AI robotics. Don't worry, because we won't be covering everything anyway this morning, because it is really a lot. And usually this type of workshop we do actually like 5 days a week for half day each day or something like that. So it's really more than 10 to 15 hours usually with a proper workshop. But due to the time constraint and the current travel restriction, we thought to give this like introduction overview over 3 hours. Okay, because Abu also has received the Jupyter IO from us, which is actually a very good self-moving AI box to begin with, and then to also introduce that particular device. And for those of you that do not have devices, we are using the okay. So as I said, we will have time until 12 o'clock for the session. If you have any questions, you can ask that questions, and we will address it during any free time. But yeah, in our case, I wish you a enjoyable workshop. Yeah, I pass the floor to Jeffrey.
Right. Okay. So thanks, Jerry. Thanks everyone for attending this, and very happy. Although I'm currently under quarantine, I'm now in Tokyo actually. So under quarantine, but I'm still very excited to do this because I've been working with UTHM for quite some time for the past RoboCup event, and it's a very pleasure to work together. And we have quite nice event together before this. So I hope like to have more interaction with the teams, and also to share the solution or the system that we have, so that later on we can work together in the collaboration project as well. Okay, so just a few things to check with you, so that we are all in the same pace and also synchronized for the workshop today. Right, so the workshop today is just an introduction, and it only have like 3 hours. So there's no way that I can tell everything. I mean, like I can like go through everything with you, but the purpose today is give you some introduction. What are we going to do? What you can do with the solution or the system that you have, and also what are the things that you can refer to, right? For example, like what are the materials that you can refer to? Where are these materials? And also we have the platform for us to have discussion as well, right? So just now, for example, like okay, the slides that you see in front of you. So I hope like you can see my slides in front clearly, and you can hear me clearly. So yeah, just to show you where you can get this thing is like if you go to our Robot for All website, you go to the courses, then under the courses you can find this rapid development system for AI and robotics. So I think like Jerry already given you like five account to access this.
Accounts, yes.
So you can go through this. So all the materials were inside here, and also just now I just arranged with you guys is like we will use the previous RoboCup team, which is this is the community group that we already have in Robot for All. So for all of you that would like to join the discussion or want to know more information, we are going to share information in this community group. So there is a forum here. So later we will post the video today over here. And later on, if you have any question or anything you want to ask or discuss, about the content today and also about the development project, please feel free to put up on the forum in the forum. Okay, so that we can refer and everyone can discuss over here. Because like if you send me email or you send me WhatsApp, sometimes I might not be able to reply you. Sometimes I just overlook your messages. But if you put here, everyone can see. All right, so everyone can try to answer and talk to each other. So I think this will be a more efficient way to do the thing. Okay, and we will share other things. For example, like I'm not sure what we will share other than the video, but I think later on we might have a lot of things. For example, like you want some source code or whatever thing discussion. Yes, you can also use this forum to share and we can discuss. All right. So I hope this to make things clear so that you know where to find the information and where to ask question. Right, then I will start the content today. Right, and also I appreciate like if you are attending, I hope you just turn on your camera. Okay, so because I want to talk to you face to face. A workshop like if me without any of your view cam, I will feel like I'm talking to the wall because if I didn't see anyone, it's a very funny feeling. Okay, so I appreciate like these 3 hour times we can like face to face each other, or those like we are not in the same space. But yeah, so and also this is a workshop, this is not a lecture, so please feel free to ask question anytime. Okay, you just can turn on your mic and just ask me questions, right? No problem. It's a discussion. And also, okay, so this one I go back to my workshop material. So as you can see over here, we have this zero. This is a pre-preparation, pre-workshop preparation. Okay, so what is this pre-workshop preparation? So today, the system that we are going to use is, I have my I/O with me. Okay, so just to show you my, I can't really show you my I/O. Okay, my I/O is over here. Okay, so this is my I/O, if you can see. Okay, so this is my I/O. So you have the same one over there. All right, so we are using the same one, but my one is the older version actually. But I upgraded, so the system almost similar to yours. So yours is the latest one, the version 18. Okay, so we are going to use this, and also for you, you have the Turtlebot 2, which is you have the Kobuki base with the structure, right? So which mean later I'm going to show you this content, right? So for all of you without the hardware, you have given the 5 account, so you should be able to download the Jupyter Sim. Okay, so I hope 5 of you already like download and install this Jupyter Sim setup properly with you. Okay, so if you haven't installed, please install now because it will take like quite some time for you to install because the file is like 15 gig. Okay, it's very big. So please download this and install. I will go through very briefly how to set up those things after this, but I hope you can work together with me. Okay, I will show you how to run the system so that later on you can explore more with the content that in this course, because you can just refer to the course and inside there got instruction and then you can work on your SIP. Okay. So because you only have 1 unit of the hardware, so it's fine. Later, I will explain to you what are the difference between the hardware and also the SIM. All right, so this will be the content. But just for the 5 count, I just want to know like if you have done the installation and setup. Anyone? Because I saw like you have the hardware and then you already like able to boot. So for the hardware should be okay.
Yeah, just to know which users are actually.
Yeah. So who is actually using the Jupyter Sim?
Yeah, if you can just shout a bit so that we
yeah, just raise your hand. Anyone?
Yeah, just open your mic and
okay. All right. Okay. 1, 2, 1, yes. 2. We should have 5 person, right?
Okay, so we have 2000 and Miro. Yeah.
Okay. Okay, so if you haven't finished install or haven't finished download, please do it now, right? Right, please do it now because it will take time for you to download, especially. It is not that fast. For sharing this big of file to download, it will take you some time. Okay, so please download it. I hope by the end of the workshop today, you're able to set up so that you can follow after the workshop with the slides and the content and your system so that you know how to explore, right? I don't intend to go through all the example and then show you all the demos within this 3 hours because it is not possible. But at least I want to show you how you can actually run it after this. Okay, so for you to set it up and have a try working on your PC is very important. Okay, so make sure that you have this part done. Okay, right. Then if you scroll through the content, you can see like I will have first I will introduce. So just now you want me to introduce, I'll talk a little bit about RoboCup, but I didn't prepare anything about RoboCup today actually, but I'll tell you a bit as an introduction. Then I will introduce what we call the Jupyter Sim AI robotic system. Okay, so this is the main thing that I want to discuss today so that you understand what is the Jupyter robot, what is the Jupyter IO, and what is the Jupyter Sim. Okay, so what are these three things and how they relate to each other? So this is the things that I hope to explain in this introductory session so that you understand and later on you can use this system for your development later on, okay? Right, then a little bit about development setup. So how you can use it for your development, which is I will explain like how you are going to use your IO together with your Kobuki and also together with your Sim to create something. Okay, so this will cover in the first part. Then I will skip through the ROS part, okay? So because this one is, it will take time to introduce what is ROS and how to start with ROS development and so on. But I'm not going to say much here, all right? So this one, I will leave it to you to study by your own. But don't worry, I will show you some steps that you can follow, right? Then after this, we will have all the demos. For example, like the speech interaction, we have the synthesis, recognition, chatbot application, and so on. I won't go deep into like how you do the development and so on, but I just will show you where are these things in your, whether your Jupyter IO or your Jupyter Sim, where are those things and what you can do with them. Okay, right. Then we have the computer vision, and computer vision got two parts. The first part is getting your sensors reading, which is for you to have the IO, you actually have the RGBD sensor, similar to the one on Jupyter Robot. Similar, although the size is smaller, but the spec is almost identical. So you can have the RGBD, which is not just the image, but also you can have the depth sensor. All right. So I'll show you how to get the data. Then after that, we have some OpenCV application that you can try some example, and I will touch a little bit about deep learning based image processing because like in Jupyter Sims we have the OpenVINO, we have YOLO, we have OpenPose, and so on that you can actually start the demos the example directly. Okay. I'll show you where are those things, and then later on you can explore more by yourself, right? Then for the last two part for this autonomous navigation and also the arm, because I'm also only have my IO here, so I don't have the hardware with me, so I can't really show you how is it look like in real world, but you have your Kobuki over there, right? So maybe I will show you how you can do the autonomous navigation on the real hardware, but you don't have the laser, so I will show you the one that using the RGBD sensor, which is you have the IO. So you can combine the IO with the Kobuki and do this autonomous navigation. I will show you how. But for the rest of you without the hardware, I will show you also how you can do it with the gazebo simulation. All right, so this is for the navigation. And lastly, we have the arm. So on Jupyter Robot, we have 5-degree or 7-degree arms. Both we have the model in Jupyter Sim that you can run. So I'll show you one very brief example that how we integrate all this model into MoveIt, and then you can do some MoveIt development. MoveIt is the planner in ROS for you to design and develop your arm manipulator. Okay, right. So this is the overview outline of my content today. Okay, so let me jump into the content now. Right. Okay, so I will start immediately since we don't have much time. Right. So the first thing is like just now I said about this Jupyter Jupyter Sims for the installation. So I will go through very quickly what you should do if you haven't done it, right? So first is like you need the VirtualBox. So this VirtualBox is a free software, open source software. If you want to try, so Jupyter Sim is the software framework that we use throughout all Jupyter system. Whether you are using the I/O or whether you're using the robot, and we have a several version of robot, all the Jupyter system, they use the same development system. Okay, so we call it the Jupyter Sim. And then, we call it the Jupyter system. Then we actually package the Jupyter Sim into this VirtualBox image that you can actually run it without the hardware on your laptop. Okay, so this is Jupyter Sim. So for this Jupyter Sim VirtualBox system, what you need to do is you just need to download this VirtualBox software, which is you can install on whether your Windows system or your Mac system. It should work, okay? And if you have a Linux system, also I think it should work, okay? Because over here you can see like it works on Windows, OS X, Linux distribution, and so on, right? So this should be able to work on any system that you have in your laptop, right? Okay, so once you install this, then you need to install this extension pad. Okay, just follow the instruction, then you run it. Okay, you add it into the preference, right? This one, you select the extension, and then you download, and then you install, and you put everything together, then you have that, right? So this is a VM VirtualBox extension pack. Okay, so you have this. So after you have that thing set up on your laptop, then what you need to do is you need to download the Jupyter Sim OVA, right? The OVA file, and this is very big. Okay, so it is, I think, like almost 15 gig, and then it divided into this 4 file, which is like 4.5 gig per file. Then you download this 4 file, then you unzip it, then you have the whole OVA file. So it's a very big file. So make sure you prepare it beforehand. Then after that, what you need to do is you need to import this OVA into your VirtualBox. Okay, so this is how you import. You put in here, you specify this. Then you need to do some setup. Okay, so in order to do the setup, you just need to select key in the information according to what is written here, and a minimum storage of about 30 gigs. So you need quite some space in order for your system. Then you go to the setting, right? Then you try to run it. Okay, so when you want to run it, you can see like the first time you may encounter some invalid setting. Okay, because the first time when you mount it on your VirtualBox, you might don't meet certain requirement because everyone have different PC system. Okay, some you have like 8 gig of RAM, some got 16 gig, some got 32 gig, and then some got like dual core, quad core, and so on, right? So you have different. So when your system have lower requirement than the one that set by Jupyter Sim, it will show this, right? So all you need to do is go through and check what is the invalid setting, and try to do the setting adjustment, right? Try to do the setting adjustment. You can do the adjustment in over here, right? So for example, like if let's say it require more RAM memory, then you might want to give more memory. Okay, or if you require more processing power, then you might need to give more processing power. So you need to make sure that you adjust all the setting until you get rid of all this invalid setting. Then only you can run this Jupyter Sim, right? So although this VirtualBox system is very convenient because you no need to get any hardware, you can run it on anywhere, any machine, but the major drawback is the performance is not as good as the hardware. Okay, right. So it is always, if you ask me, I say the best is if you can get your I/O or you get a robot. Then you can have a very smooth experience, right? if you're using this Jupyter Sim VirtualBox for educational purpose, for you to know what are those things is good. But for operation, for if you want to do a project, I don't think it's easy. Okay, unless you have very superpower PC in order to run this, or else so far my system is not I can show you like the IO will run much better than your Jupyter Sim. You can do a comparison later on because you have the IO hardware and this Jupyter Sim. But for classes, I understand that when you want to do classes, you need like everyone to have a testing. This Jupyter Sim is good for you to test. Test mean, oh, how the system look like, how the example look like. But if you want to do project, you want to do operation, I will advise you to use the hardware. All right. Okay. So, but in order for it to run, you need to make sure that you get rid of all this, which means you provide enough resources for this VirtualBox to run the Jupyter Sim system. Okay. So I hope I make things clear. Because this one, if you don't configure it nicely, you are not going to have the thing run smoothly after this. Okay. Right. So once you have this, then you just need to start the thing and run, and you should be able to see something like this. Okay, let me show you. Okay, something like this, plus the Jupyter robot logo behind, right? So I just updated my I/O, so I haven't set out everything nicely, but you have something similar like this. Okay, right. So once you run it, you should be able to have something like this. So the Jupyter Sims is very convenient because you no need to know how to install your Ubuntu system on your whatever Windows or Mac system. You need to know, right? You no need to know, like you no need to go through the risk of dual boot that might mess up with your Windows system, and you no need to worry about your ROS installation as well, right? Everything already there. And also it has much more, okay, which is I'm going to explain after this, right? Okay, so I hope up to this point, like by end of this workshop, you should be able to set up this properly, right? So hopefully up to this point, you can do it. Right, then what I need to do, okay, so just for your information, this Jupyter Sim VirtualBox system is provided for free by Jupyter Robot Company, but please limit it to educational purposes only. All right. So if you need more information about how to use this and what you can do using this for your school and so on, please consult Jerry. So Jerry will tell you like, okay, this is what you can do with this. All right. Okay. So okay, I will skip this. So I hope like you already by now you know me. So I'm Jeffrey. Okay, yeah. So for the RoboCup, okay. So let me tell you a little bit about RoboCup here. So I have been RoboCup at home committee since very early, like 2014, by under the RoboCup Japan. So RoboCup at home, okay. So over here, RoboCup is an international robotics competition that have run like 20 plus years. Okay, if I'm not mistaken, like last year is the 20th anniversary. And then it actually have many competition inside there. For example, a rescue, soccer, and simulation, humanoid, and so on. Okay, so it got many. But in 2006, they start an effort in service robot, which is they have this called at home. So at home, basically is to organize some competition for teams to develop service robot or home robot that you use in the scenario that whether we want to design in a house or in non-industrial environment. So for example, you try to imagine like if you want to apply robotics solution in like retail shops, in public area, in school, and so on. So these are all fall under the theme of at home, right? So it's a non-industrial robotics application. So, but we call it service robot or social robot. So this is what we do in RoboCup at home. And why I joined this and why also I encourage you to join this is because like for developing service robot or social robot, we actually need to develop a lot of robotics technology, of course, and also the AI technology, right? Because if you compare this with industrial robots, for example, industrial robot require more on automation technology, okay, control theories and so on. But for at home, we focus more on intelligence, more on AI, because we need to do, like, for example, like vision, perception, we need to do like speech interaction. So these are the things that require a lot of AI technology. And nowadays, for example, like all the object recognition that we use in at home is machine learning based or deep learning based, right? So it actually push a lot of development in AI. So I really like promote this thing so that more people who want to know about AI can join this. And even though your background is not robotics, it doesn't matter, because like we actually collaborate with a lot of people from computer science, from IT department, and for people that work on speech interaction, they totally have no idea about robotic stuff. Okay, they don't know about navigation and so on, but we use a lot. For example, like human robot interaction is a big part in at home, right? So uh, I encourage you to like expand this part so that you can work together with your colleague in computer science, in IT department, and so on. And even for me that involved in human robot interaction research and development, we actually have colleague from the social science department. For example, like psychology, talk about when we want to design robots for like old folks home, elderly, and also for sick children, orphans, orphanages, and so on. So when we apply this kind of robotics technology into this kind of scenario, we actually require experts from different uh, multidisciplinary. Okay, so even like not from the science department, not from the engineering department, but we can still work along together. So this at-home or service robot, in this Robot Cup, I really use it as a team so that we can actually pull everyone together to work on some meaningful application and also development. Okay, so that is it. And also for this service robot and at-home application, it's very easy for people to accept, because like a lot of scientific project, it's actually very hard to justify. Like normal people just don't understand why you do this research. But for this, it's very simple. I mean, everyone can understand, like, I want to build a robot to put in the house to help the elderly. So this one, I think everyone can understand. But the technology depth inside this development is very, very high, actually, because just to recognize object in your house is actually, you can write a lot of papers on it. Okay, right. So the scientific value and also the acceptance of public is how to say, is very easily to obtain in this development. So I encourage everyone, no matter you are a student, that you are looking for your final project, or you are a master or PhD student, you are looking for your topic, you can find a lot in this project. Okay, and if you are staff, okay, I will say that our development can actually generate a lot of research paper. So there's no problem for you to consider joining this project in order for your, whether you are doing a PhD or you do your postgrad, or even if you want to advance in your career in academic. Okay, so we have many groups, many researchers that work on this, and they actually have very good publication record. They get a lot of funding for the development and so on. Right, so that is the background for RoboCup and why I encourage you to join. Right, so I hope after this we can have more collaboration in this direction, and also for the student, you can have fun in the competition as well. All right, so that is a bonus. All right. Okay, so I need to go back to the technical content. Right, so just now I already introduced to you this. In normal workshops, I've done this in a one-day workshop, which is I mostly go through all the example in this slide, and it requires 1 day for me to go through just the example. Right, but if you want to have a development explanation, usually I will do this in, previously I did it in 5 days, right, Jerry? Yeah, okay, yeah, 5 days workshops, or we have a 3 days intensive workshop as well, right? So for this, so the content is a lot. I hope this content can help you, or this course can help you to explore by yourself. Okay, because we only have like 3 hours this morning. So my purpose here is to tell you where are those things so that you can explore after this by yourself. And since you already have the SIM and also the IO with you, there's no problem for you to actually do the execution or run the content, and you can see the result. Okay. So next, we have the Jupyter AI robotic system. So what is this AI robotic system? So up to this point, I introduced the three products. Okay, so one is the Jupyter robot, which is our open design, open source service robot platform, right? Then we have the IO, which is the one that you already have. I'm using the old version, but I already upgraded the software, so I should be having the same system, the Jupyter Sim system like yours. Then we have the Jupyter Sim, which is a virtual box. So this one is the one that you download that I explained just now, and then you can install it on your laptop, right, to run it. So we have these three systems, and how these three systems actually work together, or what are the relationship between these three is like. So we have the robot and we have the IO, and they are actually having the same system, right? So which means the software running on both the robot and also the IO are the same. Okay, they are the same. They are the and also you will see the same thing in the Jupyter Sim. So why the Jupyter system design in this way is the portability, because whether you want to use this Jupyter system for your education or for your R&D, we always prefer to only do one and can run on different places. So for example, I want to start working on my image processing project, right? So I start from the Jupyter Sim. So I do my face recognition, I do the thing, and then, okay, it's working, right? It's working. But with the Jupyter Sim, it's very slow, okay? Slow until it is not applicable in real scenario, okay? But to prove the concept without me investing a lot of money, so I use the Jupyter Sim first to try and make sure everything is working. Okay, so I prove the concept is working. Then I invest and I get the IO. So the IO will definitely boost the performance because the IO is using the hardware. So all your calculation, all your computing, everything will be boosted. So you can have very smoother and also better performance. Then during that time, you can see, okay, my image processing or my application is working fine, okay, and in real time, okay, you can use the IO and then, okay, everything is working fine, it's good. But I want to create an application, a real world application for my development so that I can show to people that how this thing can work in real life. I want to solve certain real life problem. Then with the same thing, you just need to put in Jupyter Robot. Then you can like tie it with your, for example, when you do some face recognition, then you want the robot to say something. Then you can use the Jupyter Robot to give you other functionality. For example, like move around, get something, tell something, and interact with the people, and so on. And this whole process, you no need to change anything about your core development. The image processing or the face recognition code, even the same code you can actually apply in Jupyter Sim, Jupyter IO, and Jupyter Robot. You don't need to change any single thing. Right, so that is the beauty. So you can start with your prototype, just proof of concept. Then you can have a working prototype on IO. Then you can have a working, real, complete, finished product on the robots. So that's the idea. So we design in this way that you can run your single application in all over them, and you can see they actually cover the same content. Okay, so they all can do natural interaction, computer vision, mobile platform, and ARM. But of course, in Jupyter Sim, everything will be in simulation, right? Then in IO, we actually have the vision and also the speech you can run in hardware. So which means you have the mic, you have the speaker, and then you have the RGBD sensor, right? The depth sensor is something that you cannot get from like normal webcam, because normal webcam can only give you like color information. So if you want to do that, or you want, for example, the laser scan, but you don't have the laser scan, you can use the RGBD sensor to give you something very similar to laser scan, which is later on you are going to use your I/O for your turtle board to do the navigation. Okay, so you can use the RGBD sensor to actually like simulate the laser scan so that you can still do your mapping and also the localization, right? So that is the things that you can do with I/O. Okay, so yeah, everything will be still the same. And for the arm, of course, only the robot got the arm. But in the I/O and also the sim, you can actually run the arm simulation in Gazebo. And later I'll show you like the model and also what you can do with the example in the movie. Okay, so basically this is the introduction to show you what are the relationship between I/O, sim, and also the Jupyter robot, right? So if you okay, so now once you understand this, I want to go a little bit further. Just now I put the scenario of a developer. Okay, so a developer, but for example, we also want to design this for education. So how we want to do this for education is, for example, like now we have a solution that we design AI labs for school. So AI lab is something very new. Okay, not for example, like if we want to develop an AI courses, new AI courses that focus on hardware and also practical AI development. So what we would suggest is, for example, like you have the Jupyter robots for your big projects. Then you can have the I/O for example, like for your team member. So it is very similar like your other labs, measurement labs or whatever labs that you have big equipment for sharing everyone. Then, but we also design so that you can have the I/O that everyone can run. And for students that want to do the testing at home, they can use the sim. Then you can have the whole thing, everything covered. And we want to design this system so that to help university in Malaysia and also all over the world to start up with what we call the AI education, which is not just algorithm, because now AI education is more focused on the computer science part, which is talk about the AI, talk about the algorithm, and then everything they do is like they use the server to give you the computation power. Okay, so this is the trend, but for us it's different because we want to combine with robotics so that you can have the real lab feeling, just like you do the lab, you know. You have the things that move around, you have the thing that solve real world problem, right? So that is a new solution that we want to design with this system. So I hope like if let's say UTHM have this idea that you want to start up this lab and so on, feel free to contact us. Okay, you can discuss with Jerry, and we will tell you more about how we can design this. Okay, so that you can actually create new courses for your engineering department or for your computer science department that focus more on practical AI development. Okay, right. Okay, so this is the Jupyter AI robotic system. Okay, I'm going to skip through this because I don't have time for this. But for Jupyter robot, I think like all of you already know, it have several function. Okay, some video. Okay, okay. So you can see like you can. So this one is in action. So we can see like you can move around, you can do the mapping, and then you can do the localization. And then this is for the mapping. Okay. And you can see like we actually have two kind of sensors for the navigation. We can use the RGBD, or also we got another version which is using the laser, which is I think you have one with from your Turtlebot 3, the A1, the RP laser, RP LiDAR A1. So we actually have that version as well that we can mount on top underneath the top plate, and our example actually use that to show you how to make a better map and so on, right? There we have the human robot interaction like speech recognition, online and also offline version. You can have the offline version, which is you see like how we build the language model and so on. We have the screen so that you can design your human robot interface. And you can even build the robot face there to show some emotion, some emoji, and so on. Yeah. So those are the things. Right. Okay, so this is Jupyter Robot. So for Jupyter Robot, you can have all this. Yeah, so arm manipulation, human-robot interaction, navigation, and mapping, and so on. Right. Okay, the spec, I'm not going deep into this. You can read the spec later on. Just want to like add on, we have the LiDAR version as well. So if you want to do serious mobile robot navigation and so on, you can still use this to do for the very precise localization and so on using the LiDAR system. Right. Then we have the I/O. So the I/O is very small. It's like in your palm. So I think this is a very ideal equipment for labs and so on that all the student can access to. This one actually can give you about 70% functionality of the robots. And then the sensor, the RGBD sensor, can actually have the same performance like what you have on the robots. And one more thing is like, this thing, you don't need any installation. Okay, you just plug in your laptop, whatever your Mac system or your Windows system, you just plug in and then you just run and you have all your ROS Ubuntu system and all the software package that we already like design, everything inside there. So that actually make life easy, okay? Because you don't need to mess up your system with the dual boot and so on. And also it is a very, how to say, you can share this with your computer labs. Because like if you go to your computer labs or whatever, you say, okay, I want to install Ubuntu and ROS system, I don't think your system administration will be happy. Okay, they won't like happy to do that. So we designed this so that you can work this thing with your computer labs, and you just say that we just need your computing power. You just plug in, and we have our system. After the class, we unplug the system back to normal. So that's the convenience that this system provide to you, so that we understand that it is not easy. Also, like if you want to build an AI lab, then you need to buy another set of computer just for that. It's very hard. So we designed this so that you can integrate with whatever lab infrastructure you already have, and you can rapidly convert it into the AI labs. So this will be the, yeah. So you can see like, yeah, you no need to like know how to install YOLO because you already installed there. What you need to do is learn how to do the annotation, how to learn the model, and then yeah, everything is already like set up nicely. So it comes with the Ubuntu system, the ROS system, and also all the software system already like built in. So you don't need to worry about that. You just plug into your machine in your labs, and yeah, you can start your development. And it is not live CD. So whatever that you develop will be inside the I/O. Okay, it is not live CD. So some people say that this is live CD. No, this is not live CD. So whatever that you develop will stay in the I/O that you can carry and you can use in other places. Right. Okay, so this is the I/O. Then just show you some example. You got a computer vision system that you can do a lot, like face recognition. You can have like expression. These are the things. These are all all from OpenCV example, like this one. This one is OpenPOS. And then we are using the OpenVINO framework to run this YOLO tree. We have YOLO tree, and this one is another OpenCV example. So this example, you can run it. Later, I show you the how to run it, and then you can straight away run with your Jupyter Sim or your I/O without you need to do any development. And the best part is all the example that we show you here are open source. So you can actually open up the example and do your development straight away, because yeah, we support the open source the approach, so that we can learn how people do this thing and you can do better thing from that. Okay, right. Okay, then for the I/O, because we don't have the robot, so we have to use the virtual navigation for navigation. But since you already have the Turtlebot tool, you can actually combine your I/O with the Turtlebot tool to do this navigation. Okay. In fact, this is a combination that we never done it in Jupyter Robot system or in Jupyter Robot company, right? So this is a very special case, but I believe it should work. Okay, you just plug your Jupyter I/O with your laptop, and you plug your Kobuki to the same laptop, and you run the actual navigation code. It should work. Okay, so this is for your right. Okay, so this one, and then we have the ARM as well. So for the ARM, you can see this is in Gazebo. This one is MoveIt. And we have the solver and everything, so you can plan, you can execute, and this one. And you can see like this one is the advanced version, the 7 degree of freedom. The normal Jupyter robot will have a 5 degree of freedom, and both you have both model in the SIM or the IOs as well, right? So both are inside there that you can look at how the MoveIt system, MoveIt example is developed or created. Then you can learn from there how you want to modify to simulate or to design your robot arm. Or you can even use this to learn on like planning and also the manipulation projects and so on. So you can do many things with this example. Okay, right. So the technical specs is something very small like your arm. So that's why now I don't carry my robot. I just carry a I/O. I can do my development as well because I have everything with me now. Okay. Right. So just to list now, for this Jupyter Sim, we have the latest version, okay, which is Ubuntu 18.04. Although some people might say, okay, you might want Ubuntu 20, you might want ROS 2, and so on. Okay, so those are the things that is already in development. So Jupyter Robot Company, the technical team, they're actually working on version 20 and also ROS 2 are running on the Foxy system. But because ROS 2 and also this Ubuntu 20 are the latest version, so their stability and also compatibility with the packages are still very low. So if you want to use it for production, it's actually very hard because like you have a lot of compatibility issue with a lot of other software that you might use. Especially for us, we use a lot of other things like the speech system, the vision system, Python, and so on. So we have to focus on the most stable system, which is currently the most stable system is Ubuntu 18.04. So that's why your I/O come with 18.04. And in fact, all the Jupyter Robot system now actually run on Ubuntu 18.04 with ROS Melodic, right? So our objective is to make sure that all the functionality is working fine and we don't have any compatibility issue with each other. So that's why we focus on this. But if you want to like how to say try on ROS 2 and also Ubuntu 20 and so on, actually the hardware itself can sustain. In fact, I actually hacked my I/O to put in Ubuntu 20 and also ROS 2. And I'm doing the experiment now. But this is in experimental stage, so it is not in user product. So that's why you won't get this thing in your product, because like for user product it have to be stable, right? But if you are adventurous, you can I can tell you like you can actually hack it, or you can actually consult Jupyter robot tech team, and they might can tell you something that you can actually do something else. Okay, but it's on your own risk. Okay, you hack the thing, then you might don't have the warranty and so on. But yeah, if you know what you're doing, yes, you can do that. What I want to say is the hardware actually ready for you to do this kind of development, but you need to know how to do. Okay, so for the rest of you who are still learning and just want to do your projects and so on, I will advise you to just stick on the most latest and also stable version, which is Ubuntu 18 and also ROS Melodic. Then it comes with the Turtlebot 2, which is if you plug in your Kobuki and so on, it should work out of the box. And also the Turtlebot ARM. Okay, so if you use the Turtlebot ARM, it should work out of the box together with the MoveIt example. Then we have the robot model, and this robot model is the Jupyter robot model. Okay, in Gazebo you can have the full version of the robot model in Gazebo, and we have OpenCV, YOLO version 3, OpenPose, OpenVino, PocketSpring, etc. and etc. You can find in your sim. So, but why it is so big, like 15 gig? Because it got a lot of software framework there that you can use. And everything is already like work out of the box, which means once you have this thing running, you already have all these examples in place for your development. Okay, so just another more detail to show you what are those software group. So on the left-hand side, we have the Jupyter Robot system. Okay, so these are all the software package that used by the Jupyter Robot system, right? So which means the robot system itself. Okay, so we have the arm, we have how to bring up the 3D model, simulation, the head, and the deep learning part, and so on, the navigation, teleop, and so on. Then on the right-hand side, we have the RoboCup open source example, which is Jupyter Robot actually is a sponsor of at-home education. So they make sure they work together with us to make sure that our example, the open source example, also compatibility with the hardware. So whatever that we work on RoboCup at home, it will, yeah, it is actually compatible with the Jupyter Robot system. So we can see over here. Then we have the third-party library, for example, like the 3D camera, OpenCV, the LiDAR system, the speech system, and yeah, other thing. And you put all these things together, you can like materialize things like autonomous navigation, the arm control, you have the simulation, image processing, and also and so on, right? So overview, this is the Jupyter Sim, and just to recap, this system is actually exists in all the Jupyter system, which is in Jupyter Robot, I/O, and Sim. They are all having this whole software environment. Okay. Any question? I have already like finished my overview of what is the Jupyter robot system. Oh, sorry, the Jupyter AI robotic system. So I hope you have some clear idea what are those things. And if you have any idea how you want to proceed, like use this system for your development and project, feel free to discuss with me. And even if you want to implement this in your team, in your school, in your college, yes, feel free to talk to me. And yeah, promote this to other people as well. One thing that I would like to say again is this system basically is open source. Because if you open up your Jupyter Sim or you open up your I/O, you can actually find all the source file inside there. Okay, which is very different from other commercial products out there, because other commercial products you will never find the source code, right? So but for us, because we want to promote the learning and we understand that open source is very important for your learning, and whatever techniques that you learn inside here, you are going to use it later on in your workspace. So that's why this open design and also open source approach is something that we think is very important for education. So that's why it is designed in this way. Right. Okay, so before I go to the next session, if you have any question, yes?
Regarding the I/O,
Yep.
is it possible to connect with like NVIDIA Jetson or Raspberry Pi?
Okay, so the I/O for us is to run with a laptop. But if you want to run it with an NVIDIA, I think it's possible. But I'm not sure will that give you better performance. I think it's possible. Yes, you can run it with NVIDIA and so on. But it depends on what is your objective and what you try to achieve.
Okay, yeah.
Yeah.
Yeah, I just want to ask that maybe, yeah, we can try.
Yes, you can try. Yes, I think it's possible, because like we actually can run I/O with any laptops, okay, any PC system. So which means theoretically it should be able to run, if let's say your NVIDIA is running on Ubuntu or whatever system, you should be able to run with the I/O. Yes, but I don't know whether will the performance better than if you connect it with a laptop. I think if you connect it with a laptop, will give you the best performance as compared to if you run it on a Jetson or whatever things. Unless you're talking about you need a GPU, then maybe it will give you a better GPU power. Yeah, but personally, I worked with NVIDIA Jetson board before. They are good in GPU, but they are not really good in other things. Because when you want to develop robot, you cannot work with just the eye. You still need the navigation. You still need other things. So if let's say your eye is very good, but the rest is not good, then your robot is still not good. So for me, I think the best performance currently that I have is if you have a very powerful laptop, you run the I/O, it will be very smooth. That is what I think. If you want to plug it with NVIDIA Jetson board, for example, I think theoretically it should work. Yes. Okay. In fact, the only thing that I try to make it work but it's not working is Raspberry. Okay, I want to run the I/O with Raspberry and no, it don't work. Apparently, the Ubuntu system for Raspberry and for the normal Ubuntu system, they are a bit different. Yeah, so it don't work. I don't know. If you can make it work, you please tell me. I still try to make it work, but it's not working. Okay, it's not working. And I realized the Ubuntu architecture for Raspberry and the normal version, they are different.
I will
They
ask
are quite different.
to try lah.
I try. I mean, like I tried before because like Ubuntu, Raspberry actually have very similar like a laptop, right? So I tried to connect the I/O with Raspberry, but it don't work. and I am very sure definitely it won't give me any better performance. So actually, I don't see the point. I don't see the value, except Raspberry is much cheaper than a laptop. Right. Except other than that, I don't see much usage of using a Raspberry. But if yeah, so yeah, that's my experience. So I try to make it work with Raspberry, but up to this point, it's not working yet. The best thing that that work with the I/O is like if you have a very good performance of laptop, your I/O will work nicely, especially if you give a lot of RAM and a lot of computing power. And for the I/O to run, then it will run very smoothly. Yeah. Okay.
Okay.
Right. So okay. So for the development setup, I'm going to speed up. Okay. I already spent like 1 hour. Okay. So I'm going to speed up a bit. So for you to learn, just now I already explained, but I will explain again. So you have the Robot for All courseware and learning group. So the courseware you already have access, and you can find this slide in the courseware. And the learning group, as just now we said, we will use back the RoboCup group that previously we did have. So please feel free to join the group so that we can we will share the video over there. And then later on, if you have anything you want to discuss, we can discuss over there. Okay, right. So this is the workshop course. And then for the workshop, inside the workshop, you can actually find the teaching aid, which is the slides and so on, and video later on. And the example source code are, if you're using the Jupyter Sims, you don't need to worry about the example code. You know why? Because everything already inside your Jupyter Sim. Okay. The best part about Jupyter system is all the example code already inside the hardware or the system that you are using. For example, like if you're using the Jupyter Sim, all the example and the example code, everything already inside the Jupyter Sim. So all I need to do is to tell you where are those things so that you know where to find them, right? Then you couple this with your Jupyter robot system, Jupyter system, which is either you're using the I/O, you're using the robot, or even you're using the Jupyter Sim. It all works together, right? So this development setup is workable if you are using the Sim or the I/O or the robot, all applicable, okay? Except there are a few things like, for example, like you cannot use the I/O to run the real hardware robot navigation. That one definitely, right? Because like your I/O don't have the mobile base, and same apply to your Jupyter Sims. You can only use for the simulation model, but the rest they are the same. And in fact, later on I will show you the very minimum difference between the simulation and also the real actual hardware example. They are actually using the same source code, except their output, one go to Gazebo and one go to the real robot. The algorithm are still the same. so for your sim, technically you have this Ubuntu 18.04.5 LTS version. We always use the LTS version. For all the 18.10, 20.10, we are not going to use that, right? And I don't advise you to use that as well, right? I always advise you to either use the 0.4 version, which is the LTS version, right? Okay, then we have the melodic and the link to the tutorial. If you are new to ROS, I strongly advise you to go through the tutorial, okay? Because if you go through a tutorial, although it might sounds very time consuming, but if you don't go to the tutorial and start your ROS development, you will spend more time checking Google on all the error and all the problem. Okay, you spend actually more time compared to if you spend your time on the tutorial, you actually can save more time, right? Then if for the Turtlebot 2, but the Turtlebot 2 information on ROS Wiki are quite outdated. They are still at the Indigo era. Okay, so I will suggest you that you can switch to the Jupyter robot system. Apparently, Jupyter's technical team, they already updated all the Turtlebot 2 functionality in the Jupyter Sim system. So you can actually run most of the Turtlebot 2 functionality under the Jupyter robot system. Okay, so yeah, I don't encourage you to look at the Indigo information anymore because a lot of those stuff already outdated. For example, like the ARM and so on, they are not working anymore, right? So you can actually refer to the Jupyter robot system to go further with your Turtlebot system. Okay, since you already have Turtlebot 2 system, if you run it with the Jupyter robot system, it should work, right? It should work. Then, okay, of course, our at-home education courseware, the learning materials inside there. And also, we follow the same convention by ROS. We are using the Catkin WS as the workspace, ROS workspace. So if you want to find anything, you just go to this under the source. All the example, all the open source code should be inside there, right? Okay, so ROS introduction, I'll skip this, but I will encourage all of you who just know about ROS or want to learn ROS, you can go through this example and make sure you understand this, because this information is, I think, the most fundamental and most important thing before you start your development in ROS. Okay, so I'm going to skip this. What is ROS and this one? I think, yeah, I'm going to skip this. But I will suggest you to actually try run one time by yourself. And you can run this thing in your Jupyter Sim or your IO, right? Which means you can see I actually skip all the installation steps. You no need to worry about the installation step because by having the Jupyter Sims, you already have everything installed and set up nicely for you. Okay, you don't need to worry about the installation. I remember like Professor Ubaida actually told me like they actually spend a lot of times in installation, right? And in fact, I want to share with you, I have the same problem with my student as well. Okay, every semester I need to spend like 2 to 3 weeks time with my student just to have ROS installed in their laptop. Okay, but now I'm going to like tell them, okay, you don't need to, you just skip through everything, you just use this. Then yeah, everything is how to say, it's more convenient now. Okay, so with the Jupyter Sim or with the Jupyter IO or even with the Jupyter Robot, if you have, okay, you can run all this ROS example. So you have the ROS core, you have all thing and the node. So the node concept is very important in ROS. You need to understand what is the node, what is the package, and how they work together and how they communicate with each other. The publish subscribe is the most fundamental thing, and you will use it no matter how big your project, you will still use it, right? And maybe like more than 50% of your work are actually building the communication between packages, because we as a new beginner in ROS, most of the time will be spent using how to use other people's package. Okay, until you can write your own package. The starting is always we learn how to use other people's package, put them together to create meaningful application. So how to put them together? This is the fundamental thing. So the topic allows nodes to talk to each other. And what are the messages or the data inside the topic? You can actually transfer as simple as like integer or just a few float number until very big, like the LiDAR data or video stream and so on in ROS, and they actually define the same way. Okay, you just define the publisher and subscriber, and yeah, they just transfer. Right, then the launch file is the way if you want to group all the node together to launch at the same time. Include argument, which is later on we will use this in one of our example, how you can include certain argument in your launch file so that you no need to every time type a lot of things on your terminal just to run something. Right. Then in ROS, we have this gazebo simulation, which is the official simulator for ROS. Then they built the 3D model using the ST format, which is very close to the URDF. So you need to learn a little bit about the TF, about the URDF. If let's say you want to like do something with the gazebo simulator. And once again, if you work on the Jupyter system, we already have the full Jupyter robots model, and also we have some sample environment that you can use in the example, which I'll show you where are the example later on. Right. Then for ROS, I will encourage you to first go through the tutorial. Okay, you don't need to install. You just start your Jupyter Sim, and then you can go through the tutorial. You can do all the tutorial inside there. Particularly, I want you to practice on the publisher and subscriber. Okay, so that is very important. Make sure you fully understand what is publisher and subscriber and all the line in the example. Make sure you understand those things, because without knowing what is publisher and subscriber, you can't actually go forward with your ROS development. Okay, so that is how important it is. Then after that, other concept, for example, like what is TF, what is LQT, what is URDF, what is SDF, and so on, ROS time, ROS back. So these are a few concepts that after you finish the basic, then yeah, I will encourage you to look at all this concept. And then for the communication in ROS, actually got this 4 types. So the first one, which is the most fundamental and the most important one, is the publisher and subscriber. So that one, I will strongly encourage you to go through the example until you know every single line. Then other things, for example, like services, if you want to know service, action lib, ROS action, and also parameter server, which is some example you can actually see like they have this param, which you can define. That you can do, especially if you want to do experiment. This parameter server is very handy for you to do the adjustment during your testing and so on, right? And then you will use a lot of action in, for example, like navigation, use the move base and so on. Yeah. Okay, so those are the basic. And for you to start your development, okay, so once you have some idea about ROS, so you want to start your development, you can go through this example first. Okay, so the first example is, of course, the publish and subscribe example. Okay, so you do the talker and also listener. This is the ROS C++. This is C++ example, and you can find both C++ and also the Python example in the tutorial. Okay, you can go to the Python first. Then after that, you look at the C++ example. It depends on what is your background. You prefer the C++ or you prefer the Python. But the current trend is like almost 80% of the example out there are in Python. Okay, but if you work a lot in OpenCV, vision system that you work with like GPU and other things that will connect to hardware and so on, you still need a lot of C++. All right. In fact, our example in OpenCV, they are all in C++ and so on. So I will suggest that you need to go through like both C++ and Python. But for high-level development, for example, if you want to work on the speech system, yeah, mainly in Python and so on. And in fact, you can do a lot of machine learning now with just Python. No longer you need any C++. But no harm for you to know C++, because like a lot of low level, if you want to touches the hardware, especially, it still require a lot of C++ example that you need to go through. But ROS, what the beauty in ROS is like, even if you work with a C++ example, you can still write your program in Python and interface them together. No problem, you can still do that. Okay, so the reason why I say you need to learn C++ is not for you to write your program, but it's for you to understand the package that you refer to. Because you want to look at their code and you want to see what's happening inside there, you need to understand how their code work. So that is the part that you need to learn the C++ part for ROS. Then these are all the, okay, to analyze the topic and also the publish subscribe thing. Okay, so you just go through this and then, yeah, okay. Okay, so as an exercise, please go through the first link to learn how to create a package. And for beginner, I will strongly recommend you don't go to the CMake list and so on. Okay, just create the package and stop there. And then go to the publish subscribe. No need to read about how to write your own CMake file, okay? Because it will confuse you a lot from the first. Okay, just create the package. Actually, the create a package, I just want you to read the first part. Okay, how to create using the create package command. After you create, that's it. Go to the second link to do the publish subscribe. Okay, for the time moment, no need to read how to write the CMake list, because like it's not easy for you to understand that. And if you make any mistake, your package is not going to compile, and you have a lot of very annoying errors and so on. Okay, so just create the package and start your publish subscribe example, and then you start to like understand how to write a node. Then later on, how to put them together into a launch file and how to launch them together and so on. Okay, so these are the process how you want to start with your ROS development. Okay, so with that, you have any things you want to ask? Okay, just want to show you some examples since I don't have any example. So whatever that I say just now, so once you boot up your Jupyter Sims, you can actually do this. And yeah, everything is just, okay. So I can do the ROS launch, sorry, is it run? I cannot remember. ROS C++. Tutorial. Is it this one? Wait, cannot remember. Okay, let me go back. Okay, ROS run. Okay, this one. Maybe I just do like this. Okay. ROS run, ROS C++ tutorial. Okay. Yeah. So you can learn how to start your ROS tutorial by using, yeah, the Jupyter Sim, without go through the installation of Ubuntu or the installation of ROS. You can skip all those things and straight away start your learning your ROS and also the tutorial. Okay, so yeah, these are all the things that you can run. And you can also create the package. So let me show you why is you go to your cat team, WS and SRC. So over here you can see like all the packages. Okay. You can see like your basic functionality, your Jupyter robot and all this thing. Okay, let me show you in the file form. Maybe you are more familiar with this format. Okay, so if you go to your home, then you can find the cat team WS, and then you can go to the source and you have all the packages inside there. And these are all open source. Okay, so basically you can see, you can find all the source code over here. For Jupyter Robot System, yes, we have all the function. This one is especially for the Jupyter Robot System. Okay. Then if you want like basic function package, like your Astra sensor, your dynamic cell, motors, and all those things. Yeah, these are all those. And even like the RP LiDAR already there. You just need to plug in your LiDAR and run the example, it should work. Yeah. So these are all the example that you can refer to. You can actually copy the source code and start do your development. Yeah, and this one is for our at home example is over here. And for the Turtlebot, yeah, so we have the whole updated Turtlebot source code over here. So you can use this for your Turtlebot 2 as well. And it should work under the melodic version. Right, so this one is the latest one that you can make sure that it able to run on for your Turtlebot system. Okay, right. So yeah, so those are the things that you can find in the SIM or in the I/O. Okay, so I have gone through this. Speech synthesis. Okay, so up to this point, I will want you to do some, because like I've been like talking 1 hour plus. So maybe I would like to invite you to work together with me. Okay. So for any 5 of you that you already installed, and also for Professor Abu Ubaidah, we can try. Okay. I want to make sure that the thing not just working on my side, but also working on your side as well. Okay, so for this speech synthesis, I would like to know who are ready to do the testing. Okay, so maybe I think like this first example, everyone can try. Like it's very simple. Just need to run this 3 line and make sure that you can hear the voice. Okay, so maybe but anyone can start doing that, and you can share your sound to make sure that I can hear it. Yep.
Okay.
So maybe Professor, yes, maybe can start with you. So you just share your screen and then run this 3 line and let us hear the sound from the I/O. Is that okay? Okay, so I'll stop my screen and let you share your screen, okay?
Can you hear my voice? Okay.
Yes.
I'm sharing my screen.
Yep.
Okay.
Okay, good.
So oh, the code is already gone. So Roscore. So
yep.
we already opened. I already tried for the hello. So
it's working
and talker. And
okay, yeah. So it's working. All right, it's good.
Next one is the speech synthesis, right?
Yep. Speech synthesis.
Where can I check the code?
You can actually tap. Oh, where can you see the code? Can you access to the Robot for All?
Okay. Maybe here.
Yeah. You just go to yes. You just go to the speech synthesis. Yes, correct.
Okay.
Yeah, it's over there. Maybe the next one, not this one. The speech synthesis.
Speech synthesis. This one.
Yep. Yep.
Okay. So I hope the other student can also prepare. So after this, maybe.
Yeah. So I want all of you to try to run the example.
Yeah. Okay.
Yeah. Instead of me running, you run will be more interesting.
Play maybe this one. Oh.
Yep. Correct. So you just run this and then you open another one.
Rose round sound. Okay. Sound.
Cross run, then you need a space there.
Yeah. Okay. So when I copy the space was not.
Oh there. Yeah. When you copy, then you need to adjust the spacing because it's PDF file, so it is not really.
Yeah, it's okay. So save and
the ROS run. After ROS run, you need a space there.
Okay. So
and maybe the double quote. Maybe you want to retype the double quote. Yeah.
Yeah.
Yes. Yep.
Yeah, okay.
Yep.
Okay.
So over here, what you can see is like the feedback is like saying the content and also the voice and also the volume. So you can actually change the voice and the volume if you want, which is we have the information after this slide. on the second slide.
Okay. So so should I continue this?
Yeah, if you can.
Okay. This one, right?
Yep. Okay, no, this one. Okay, this one is after you have installed the sound package. Okay, so can you just show the second page? Let me explain first. So for the second, this one, the festival. Okay, so this one is to show you how to do the speech synthesis. But the next page, okay, please go to the next one.
Okay.
The next page is if let's say you want to change the voice, okay, you can actually add additional voice package from this a few methods, like you can install by depths. Got few example. You can see there's a Dawn, Fastvox Dawn example over there. Then to implement it is like down there you can actually specify instead of the default voice you can use another voice and you can hear like different. Yeah, because a lot of user actually come to me like say, can they have like female voice, children voice, can they do something with the voice and so on. Yeah, here got some example or some more information that you can actually play around, right?
Okay.
Okay, but yeah, you don't need to actually go run this, but maybe you want to show us the next example.
Okay, speech recognition. So I think how about Faisal? Faisal,
Yep.
are you ready? Because I just want to see if my student can also
Yep.
do this.
Yep. So yes, feel free anyone, to run the, because I want you to learn how you can actually use the courseware to do your learning. Because we are not going to be able to cover everything in these 3 hours, so just to let you familiar with the system.
Yeah, maybe the basic. So I didn't hear his voice. Faisal? Faisal?
Yes, sir.
Okay, Faisal, can you share your screen?
Yes.
Can you do this example on your
Yeah,
computer? Okay, okay.
For the next example, the speech recognition. Okay, first thing is you need to, okay, you share the screen first. I'll give you some instruction what you're supposed to do.
Okay.
Okay, right. So okay, go to your VirtualBox.
Yes.
Are you running on VirtualBox?
Yes.
Show us your VirtualBox.
I already run this.
Oh, okay.
Oh, okay. So this is a VirtualBox. Okay. So first thing is you need to adjust your microphone. Go to your system. Oops. No. The Ubuntu system. Yep. Go to the sound and make sure you go to details up there. Yep. Okay. There's a sound. Yes, correct. Right. So you can see over here this is output. You can do the test speaker just in case you cannot hear the voice. You can do the test speaker to make sure that you select the correct interface. Then you go to the input. Okay, so this one you can select the microphone that currently connect to your, I'm not sure which one, but I think this one should be working because you got the input level. Can you see like the input level is jumping when it hear my voice and so on? So up there's actually the place for you to adjust the gain, right? Okay, so this one is the input volume is the gain. So you need to adjust this gain later on when you do the speech recognition in such a way that when you are not speaking, the input level should be showing nothing. But when you say something, the input level should give you a maximum amount of level. Okay, so this one will be very critical when your surrounding is very noisy. So when your surrounding is very noisy, you should put your gain as low as possible to make sure that when you are not saying anything, the mic should not pick up anything. Because if let's say your gain is too high, your mic is pick up some noise, even you're not saying anything, your recognizer will start to recognize the noise and you will get false recognition. Okay, but of course, if you put your gain too low, sometimes even if you shout, the input level is still very low. So you need, that is a trade-off. Okay, and this is about the signal noise, how to say, signal to noise ratio and so on. So this will add a lot of research on it, how to do noise cancelling and so on. But this part is the very basic part that you can adjust to make your speech recognition workable in your example. Okay, all right. So with this in knowledge, you see how you want to adjust the input volume, and you can start running the speech recognition example. Okay, so yeah, please excuse me because apparently like the quarantine officer is going to call me. They are checking on me every day. Okay, never mind. Just please show us the example. I just need to mute myself. Okay, you need to take some time to type this.
Yes.
Yes, the whole thing.
So all the other members can also check Faisal programming. Maybe you can correct him if he written something wrong. Yeah. And Amirul, I think Amirul, you also have the simulator, and Zubair. So I think you guys can also try the same thing on your own computer.
Okay, one thing that you need to you need to take notice is like the username of the Jupyter Sim and IO are all using the same username, which is the Mustar, MUSTAR. Okay, so you need to know like this is the username that is set in your Jupyter Sim and also your IO, and also the password, the sudo password for the system is also Mustar, right? Okay, just in case that you need to do some sudo later on. Okay, it's working. Good. So now try to open another Windows and see the KWS data. Gross topic echo. The next line. And then you can start talking to your mic. Okay, you need to open up the KWS list.
KWS list.
Okay, so you go to your file, yes. You go to the directory. Can you see like the directory? Basic catkin, yeah, source, then basic functionality, pocket spin, and then demo. Okay, so this one is command, yeah, voice command, yes. So these are the few words that you can try. Okay, so I think like now you have a lot of false detection, which means your speaker, sorry, your mic volume is too high. You need to like make it lower.
Back. Forward. Left. Move.
Well, you need times to adjust. Don't worry about that. Okay, but you can see it start to recognize you, right?
Yes.
Okay, so now maybe you want to try to open up the robot model, simulation model, to see if you can use this to control your robot.
Gazebo world.
Yeah. The next one. You just follow the example. But this one may take some times to run, so I hope. Yeah, continue.
Continue.
Yep. I hope it works. You are using the sim, right? I hope your PC is strong enough.
Not fast as Ubuntu on the.
Okay. But it looks fine. Yeah, it looks fine. Let's see. Ah, good. So we can scroll it down in there. So as you can see, it start to get slow and so on. Yeah, because it's like VirtualBox. Okay, and this is the Jupyter robot model. In fact, you can have the arm if you specify the arm. Okay, now you add in one more line so that you can connect your voice command to the move base. Then you can start to like voice command the robot to move around.
Using this.
Yep. No. The top one. The ROS run pocket spin voice control example.
Oh yeah.
Yes, this one. Control example.py. Yep. Then you can look at the gazebo and yeah, the robot should be start moving. Can you see the ROS topic? Okay, you say something.
Move.
Yeah, can you see the robot is turning and it start to move?
Yes.
Okay, so this is how you use the speech to control the robot. But over here is in a virtual robot. So you can implement the same example in real robot as well. Okay, so basically that is the whole example. Any question? And if you want to know how this thing is done, you just need to dig out the example and you copy the sample code and yes, you can do your projects. Yeah, you already can voice command your Turtlebot to move around with this example. Yeah, but later on, you just need to like, instead of pass this to Gazebo, you just pass this to your Turtlebot too.
Real robot.
Yeah, then you can, of course, you can change and other things and so on. Any question from other member? Any question?
I'm trying this. Yeah, it is working for me also.
Yep, good.
Yeah.
Right, so it's okay. Right. Okay, so go back to the slide. I just want to, we are not going to run another example, but I want to give you extra information. So for the next one, we actually have this LM model. So just now the example is using KWS model, but the next one is LM model, but you don't need to worry, okay, they just work identically. The only thing is this LM model, we got a way to can change the database. So just now you see the KWS list, we have the back, forward, and so on, right? So you might want to think like, okay, if let's say I design for my competition, I might want a different database for the wording. So how to do it? You can use this LM model, and all you need to do is you just follow the second line, creating a vocabulary. So all you need to do is you go to this RoboCup folder, you change the corpus, and you upload to the website. to create the LM file and also the DIC file. Then you link it to your LM mode example, and that's it. Okay, so can you please go to the RoboCup folder?
RoboCup.
It's yes, source, then under this, yes, correct. So in the speech, correct, RoboCup folder. Okay, so you can see in this RoboCup folder, these are the file that generated from the CMU website. So all you need to do is you create a corpus file in the first file, you open the first file, yes. Okay, so this is the database that you create. You just create a corpus file, you write all the lines that you want, okay? Then you save this file and upload to the website that I put the link there. You go to the, yeah, so that is the link. Yeah, so this website. So all you need to do is you upload the corpus file to this link. Okay, you upload. Is it okay? Look. Okay, it might be very congested because you are running a lot of. You are used up a lot of bandwidth now. Okay, don't worry about that. Okay, so all you need to do is you upload the corpus file to this website and it will generate all the file that you need, similar like the one in the RoboCup folder. Okay. Okay, don't worry about that because like you can look at it later on.
Okay.
Just go back to the slide. Okay, so all you need to take note is you need to make sure that when you run the launch file, your dictionary and LM, the path should be correct. So which means if you updated your dictionary file and LM file, make sure you link to the new file. Right. And you can actually write the dictionary and LM file path into the launch file as an argument to make it short. So that one is the third part of this example. All right. So you might find it hard to follow what I say, but don't worry. Later on, you can still look back this video. You need to slowly look at all the example file that I say. Then you will understand what I mean here. Okay.
Okay.
All right. Okay. So that's all for this speech recognition. Do you have any comment or any question?
So regarding this one, we just need to upload to the LM tool new.
Correct.
Our corpus.
Yep.
And then we'll give out a dictionary and LM file.
Correct.
So we can either replace our current dictionary and LM file, or we can also make like a how do you say direct our program to that dictionary.
Correct. You can change the path or you can replace the file. It's up to you.
Okay. Yeah.
As long as you tell the lm.launch where to find your dictionary and LM file.
Okay. Yeah.
Okay, and you can write this argument in your launch file so that every time you don't need to type so long command. Okay, you can even put that, right? Okay, so that's all. So maybe if we can go to the next session. Okay. So for the next one, maybe you can mention the last one. Okay, maybe you can go to the next one. Yeah. Okay, this one I'm not going to run the example, but I just want to show you what is that. So just now for the podcasting, we are using what we call the offline speech synthesis and recognition. Offline means everything is actually run in on board. So you have the source code, you have everything over there that run locally. So even you can open up all the source code and look what actually happening down there. But nowadays, actually a lot of online API that let you do speech recognition. Google Voice or Google Speech or the Google API, Amazon, and a lot more, okay, you can use. And over here, Jupyter Robot actually show you one example from China, which is the Xunfei example, that it used the Xunfei online API for speech synthesis and recognition. This one you can go through later on by yourself, no worry. What I want you to take note over here is like for online API, the advantage is you no need to specify the database. Because just now, the example I show you, the KWS and LM, we always need to specify a finite amount of dictionary, which means you cannot have like open conversation, right? But online, they are actually not very small dictionary, but because their dictionary is so big, because they have a very big server, so basically whatever that you can say to the system is inside the database. Okay, almost all the word they have in the database. So that's why they can afford to like, yeah, you don't need to build your database, you just say whatever and it will recognize. So that is the benefit of online system. Because it got a very big infrastructure for the processing and so on. And the accuracy for online API actually is much better compared to the offline version. The accuracy, yeah, because your center is much more complicated and so on. But the only drawback is it requires internet connection. So if you want to run this example and you are not connected to the internet, it's not going to work, right? It's not going to work. And also the second problem is the latency. It might be slow if, let's say, you have very limited internet speed or access, bandwidth is very small, or your speed is very small, it will have very big latency. That's a problem. So a good strategy that everyone actually use it now is you combine offline and online together to become what we call, for example, you have the OK Google. You know why Google need you to say OK Google before you start speaking to the agent? Because OK Google is using the offline version of recognition, then it, how to say, record whatever that you want to say after OK Google and send it to the server for the online version. Okay, because the online one, it don't make sense that you keep on sending your voice to the server and do recognition 24 hours. It is a waste of resources. It's not optimized in that way. So a better strategy is always you combine offline and online together, because offline you can run it continuously, no problem. So the OK Google is the proof to show that even for Google and other people, they are using this strategy as well, because this is apparently the best strategy currently, is to combine the offline and online for the more optimized speech recognition. Okay, right. So this one you can run it later on by yourself. And down there we actually have two chatbot example: the talkback and also the party bot. So I already show the path to the source code. So you can open this thing, study by yourself, and see how you want to create your own chatbot. All right. Okay, so if you are interested, you want to like create a chatbot, and yeah, you can. We already have example in your system, and you can just look at it and yeah, make the example. Right. So that's all for the speech. So can we go to the next one? Okay, maybe another person can try to show us the example. Anyone? So we are going for the computer vision. So someone that would like to work on the computer vision, you might want to show us the example.
Okay. Yeah. Maybe Faiz from Faisal team. I think Faiz, can you share your screen? I think he has a very powerful computer.
Okay, yep, that's good, because the deep learning part will be very slow.
Okay. Zulfazar Fahmi. Okay, yeah.
Okay, so please open up the computer vision part and let's run some example. So can we have the slides? Right, okay, good. Okay, so I skipped through the front part. Okay, we just go straight to the visual perception. Okay, right. Okay, we skip through all this and just straight away go to the visual perception. Okay, over here. Okay, wait. Yes, this one. Can you make it bigger a bit? Yep. Okay, over here I need to explain. The example here is for USB cam, which means is cater for Jupyter Sim. So for Professor Abu, you might want to use another example that I actually have in a separate file, but I will tell you how is it. Let's try with the USB cam first, okay? Since for the Jupiter sim, you only have the USB cam. So can you try bring up to see if it able to run your camera? No. You need to do the bring up first.
Then you need to launch the USB.
Yes, you need. And also, are you having a USB camera or a separate one?
A separate.
A separate one. Okay, so a separate one, maybe in your VirtualBox, you need to enable first. You go up there. There's an input. Right? There's an input there. Can you hear me? Up there, there's a device or input, if I'm not mistaken. Okay, so you need to enable your USB cam first before you do the bring up.
Nampak input atas.
Other. I'm not sure it's input or devices. I cannot remember. But you need to like click on it first. Up there.
Go up.
Atas.
Go up.
Atas lagi.
Kiri.
Yeah, yes.
Ada.
Okay, go to the devices. You add USB. You're using webcam integrated or USB?
USB.
Okay, USB, then maybe you need to go to the USB part, not the webcam. Right. Is there over there? Okay, can. And then, okay, try again. Tak boleh ke? Wait. USB is, I think something wrong. Can you run other example? Because like apparently like your workspace is not correct. Are you running something behind? Oh, okay. Please shut down whatever that we are running. Okay. Okay, run again. So first go to the bring up. Try the bring up. No, not this one. The bring up for the camera. Yeah, this one. I think you need to check the spacing. I think something wrong with the spacing. I will suggest you to type it instead of copy paste. I think something wrong with the spacing. So yeah, you need to like be careful on that. Yes. Okay, good. Right, so it's working. Right, no problem. So we can proceed with the next example. What is the next example? Okay, what's the next example? We have the cam shift, right? Okay, this one is just to show your image. Okay, you already show, no problem. Okay, you need to proceed to the next one. Yeah. Take a photo. So you already bring up. So you just need to run the first line. Yeah, this one. Buka satu lagi. Okay. Sorry, how come? Oh yeah. Okay. So this is a part. So can you please open up the takephoto.py file? I need to explain this thing. Yep. Go to the take photo. Yeah, vision. Script. Takephoto.py. Correct. Okay. So over here, what you need to, you scroll down, you can see there's a topic over there. Okay, yeah. Just connect to this one. So if you are using the RGB, the topic is is not this one, but okay. Can you go to the? Can you see the image topic in the slide? You need to change it to USB cam image raw instead of camera top or camera RGB. Yeah, you just change the front. Yes, correct. USB cam image raw. Okay, save and run again. Run again. Yep. So try to find your file. Home direct. You go to home. You go to home. Can you see the? Yeah. So with this you can take photo, and you try to imagine if you combine this with your speech example, you can use voice command to take photo, right? You can just shout to your robot, take photo, then yeah, it will capture your photo. Yeah, so that is just a very simple example. Maybe we go to the next example, will be more fun. Let's go to the OpenCV application. Next one. Yep. Okay, this one more fun. Right. Let's look at the last one. You already launched? Yeah. No. Up. Yes. Launch node. This one. Correct. Open underscore. Yes. Camshift.launch. Then your space image. Okay. Yeah. You need to specify your topic. One image only, not two. Yep. Okay. USB underscore cam / image raw. Something wrong with the typing. Semicolon and yes, yeah, that one. Yep. Yeah. Okay. So over here, yeah, can you find something like red color or some unique color that you can show in front? For example, like you can show like a bottle or whatever thing. Then you try to select the path. Yeah. Okay. Then you use your mouse to select one part of it. Yep. Select. Drag. Click and drag. Okay. Enough. Okay. Then you try to move around. Yeah. So it start to do the tracking. Right. So what you need to do is it actually have the topic to show the center position of this tracking. So you can straight away run this, and then you can subscribe to the center point, and you can make your robot to follow certain red ball or yellow ball, or and the robot can move. So these are the examples that you can play around later on. Yeah. Okay. Let's go to much more. Let's go to the next example. We got a lot more example. Okay, the next one will be interesting part. So it's the face detection and so on that you can try.
I have a question regarding the bring up. Can we use
Yep.
webcam?
Can you what?
Use webcam.
Yes, you can use webcam, of course. You need the topic. Yes, you can use the webcam and so on. But actually, I would like to show the depth part as well. But it's okay. Yeah, your I/O can actually see the depth information as well. So maybe that part I can show you. But please run through this example first, or at least run the face detection. Yeah. So you can see like it automatically can track your face without pre-learning. So which means this is actually using a deep learning base, which is they already like have the model trained with a big amount of faces, so they can recognize what is a face, where's the location of the eyes, and so on. And you can have multiple person in the frame, and it still can detect. Okay, right. So yeah, so you want to run okay, so this is the face detection. I think the rest is very similar. If your PC is okay, let's go to the next one, the deep learning based image processing. Yeah, this one. So yeah, you may want to use the open pose or the YOLO. Up to you. Okay, but this one I think you need to change something. You need to change the topic. Yeah, you need to change the topic. Let me see what are the things that you need. You need to change the topic. You need to change the topic. Okay, so instead of that, why don't like, or we use the IO to do it. So can I have like Professor Abu Baida to show this example?
Oh, okay.
Yeah, because I think this one will run better on the IO compared to Jupyter Sim.
So now I will share my screen.
Mm-hmm. Yeah, the deep learning one. Yep.
Okay. So I
Okay,
should.
so it's not this one. It's not this one. So what you need to do is you use the ROS launch Astria camera Astria undergo. Okay, let me tell you. Okay, ROS launch.
I'll just close
Yeah,
the
you
other.
close all those things first. Bring up for the IO is a bit different. Yeah. Okay, so ROS launch. Astria underscore camera Astria.launch. Yeah, you can tap and it should come out. Yep, launch.
Okay.
Yep, this one. Then the rest should be the same. You can straight away go to the YOLO one.
Okay. Now this one.
Yep, yep. Yeah, be careful on the spacing. ROS launch after that you Yep, okay. Yep. So maybe you want to try to get some object. There is actually a list. If you find in the folder, it actually got a list.
In folder. So I go here. Which one in the Jupyter?
I think it's in Jupyter Robot module, Robot Vision. Open Vino, was it? I
Module.
cannot remember where is it.
Vision. Open Vino. Okay. And then in the
Model, YOLO version 3, and then name, if I'm not mistaken. Yeah. So YOLO, yeah, name. So these are names. So inside the names, these are all the objects that can be detected by the current model. So we can try to fit glass, cup, fork, and try to see if it's work.
where can I find? Maybe mouse. Let's try mouse.
Mouse, but the person is quite stable, right? It can detect the person. Yeah, mouse, maybe you want to see a little bit like mouse.
Maybe lighting.
Donut.
The lighting because I have lights on the back.
Yeah, your lighting is not very good because like all this thing. Yeah. But just want to show you this one. We already have everything configured and running, and all you need to do is learn how to create new model. And yeah, you already have the YOLO running. So we use the pre-made data, the model, but of course you can try with other model, remote. I think a cup or something will be, yeah, look much better. Knife. Yeah, okay, the cup. Yeah, I detect the cup just now. Okay, anyway, yeah, it's okay. I think the interesting part, maybe the open post will be more interesting. Maybe you want to try the next example. Oops. Is that okay? Is it okay?
Yeah, it is working.
Because I don't see any update over here. Oh, okay, good. Yeah, it's working.
Yeah, my internet.
Yep. It's okay. It's okay. Yeah, at least like I mean the skeleton is already start to detect your arm and your head. Yeah. Okay, so this is also working. Yeah. So I think I think it's quite stable. So far, all the demos and then I let people run on it. I think it's okay. The next one is the interactive phase, which is it will tell you like the age, the gender, the emotions, and so on. So this one you can use it for like to recognize certain person other than the name, right? Yep.
I'm a bit younger now.
Yeah, it's good. Anger, neutral. But the gender is quite stable. I can say the gender is quite stable. Younger is good.
Yeah. I think it's about like 5 years, something like that.
Yeah. Okay.
It's good.
Right, good. Okay, so we can go to the next one. Okay, so vision basically is like this. What useful for you is like we have all the example already in place. You can straight away use, or you can dig out the original source code and see if you want to modify anything. And also for the deep learning based stuff, we already have all the framework done inside there. All you need to do is like learn how to create new model or try to connect this with your application so that you can ROS topic the result to your application and you can do a lot of things from there. Okay?
Okay.
Right. Okay, so let's move to the next session. We have the autonomous navigation. So you want to try with your Kobuki or we try the simulation model?
I think it's better with simulation because I'm at home right now.
Okay, all right. So let's go to the simulation or any of your student want to try?
Okay, who wants to do it now? Maybe Pfizer or Fami. Okay.
Yep. Any of the student can try. So simulation should be workable on your laptop, but maybe a bit slow because it's involve a lot of gazebo simulation. So the rendering might take some time, but it should work. Yeah. So for the simulation, you just open up the simulation slide. You just go to the straight away go to the gazebo simulation page.
Gazebo simulation.
Down there. Slam map building. Yep. Okay. Yeah, you can scroll down because a lot of information. Yeah, you can just scroll down, down, some more. Okay, yeah, this one. This one. So first, you need to have the simulation model first. No, not this one. The one before. Before this. Yeah, this one. You need to run this first. So this time, instead of using the default scene, so we are using the Jupyter Robot Office, which is the test area in Jupyter Robot. That they actually have the same model, real life and also simulation. They measure all the measurement and make sure that the real life space and also the simulation space, they are having the same, exactly the same measurement. And the interesting part about this is like whatever that we test in simulation, we can actually use the map from the simulation in real world, and we can also use the map from real world in simulation. The accuracy is very high. Okay. Yeah, I think something wrong with the spacing or some, yeah, you need to check the typing. Yep. Okay, it will take some time. Okay, yes. So this one is the same test area in real life and also in the PowerPoint slide. You can actually see the actual photos of it. Okay, but anyway, so this is the thing. So the next one is we run the SLAM map building. We use the G mapping. Yeah, the next page. You can just run, and then this one we are using the RP LiDAR so that you can have a better performance. In fact, this one you can use it for your turtlebot as well. You can use the RP LiDAR that you have and put it on the turtlebot, and it will give you a very similar result. Ross launch. Don't have the JU. Ross launch. Yeah. Yes.
The second one.
Okay. Can. Okay. The next one. Yep. Correct. Next. Yeah. Okay, your RVs should be up. All right. Okay. Then the next one is your teleops. Okay. Yeah. actually Alt space keyboard. Yeah. Okay. Right. Okay. You can use this one to control the robot the robot to move around, and you can see it start to update the scan. So you can see the scan, and because it's using the laser, so the scanning is quite, I mean, updated faster than the RGBD. Yeah, you can move around. Yeah, so this is how you build the map. And in fact, if you have the same environment in real world, you can save this map and use in the real world.
Laser is quite accurate.
Yeah, because it's using the laser. So and then this is in simulation, so the noise is relatively low. But if you are using the laser in real world, it is actually quite similar. The how to say, the performance is much better than RGBD sensor. And you can have very clean scan like this. Yeah, you can try later on with your Koki and also your RP radar. Right, so after you have satisfied, you can save the map, but don't worry, you don't need to save because we already have the map. you can shut down and go to the next example. Yeah, you can go to the next example. So the next example is use the map and then you can do the navigation. Yeah, just go down. This one no need. Okay, this one, yeah, start from here. Yep. Okay, moment. All right. Zibo AMCL. Okay, good. Launch space. Yep. Map file. Okay. By AML. Okay. Yep. Okay, so all you need to do is you can use the 2D navigation goal to specify the goal, and you see it actually run. Yeah. So can you see, like, it actually able to create the path? Path planning is working. Then yeah, the robot control using the path planning and start moving to the point. And the corner is a bit tight over there, so sometimes the robot just cannot pass through. You need like a few more waypoints to make it pass through. Yeah, maybe you want to give another, yeah. Okay, pass through. Okay, it passed through. Then it reached the destination. Yeah. Okay, so that's the idea. I mean, you can do this, and in the slide, we actually have another way. Is like you can do exactly this whole thing using code base. Yeah, if you want to implement in Codebase, I already written a script there, the navigation.py. All you need to do is take the coordinate, put in the navigation.py and run the code. And you will have the same result like what you did in Arvis.
Okay.
All right, any question? So that's all for navigation actually. Anything you want to ask? Yes.
So in the Jupyter robot,
Yep.
there has two camera on the top and bottom.
Yep.
So what is the function camera on the bottom?
Okay, the bottom one, you can use the RP radar for the. Okay, this is by experience. I'm not sure whether it's accurate or not. Usually, when build the map, I will use the RP radar. But when I do navigation, I will use the bottom camera. The bottom camera apparently works better than the RP radar in AMCL. Okay, because RP radar is 2D. So when use it for object avoidance, it's actually not so good. But when we have a 3D camera for object avoidance, it's actually better. Maybe is my feeling, because I don't do any experiment to do the comparison. I don't have any quantitative comparison between these two. But based on experience in real world, okay, because like in Gazebo, they are in a perfect world, so it don't really give you the real data. In real world, when I build the map, I will use the radar. But when I do navigation, which is I do the AMCL, I will use the bottom camera instead of the radar. Instead of the radar. I use the radar to build map, but I use the bottom camera for the navigation, for the AMCL. Okay? And also, during your navigation, you might want to detect some object on the ground. And radar can't actually give you any information about what object is that. Yeah, you can only find obstacle, but when you want to recognize certain object, for example, like when you move your robot around and there are some obstacle on the ground, the only way you can do is you do object recognition using the bottom camera. Because by using radar, I think it's very, very hard for you to try to detect or try to recognize what object is that. Almost not possible, because you only have like a 2D scan and you don't even know the shape, you don't have the color, you have no way to know what is that. So the bottom camera is for you to do a lot of this kind of like, when in your navigation, you want to recognize the object and so on, it's better to have a RGBD. So that's why the design for Jupyter Robot, we have both radar and also RGBD at the bottom for the navigation. Okay. Yeah. Right. Any more? Any more things that you want to ask? Okay, if no more, then we proceed to the last one. The last one is the robot arm with move it. The last one, I don't have much example to show you. We only have one example, which is this one. And then there's only one line, so maybe you just run it and show to everyone. Yeah.
Close all.
Yeah, close everything and just run that one. Okay, hold on, I got a phone call. Hi. Konnichiwa. Hi, thank you. Hi. Hi, onegaishimasu. Hi, onegaishimasu. Hi. Okay, so this one maybe I need to explain a bit, right? So we have this. So you actually have three groups of model. The first group, if okay, you can go to the planning group. Can you see planning group? Yeah. So planning group, you got the arm group, gripper group, and the head group. Okay, let me explain what is that. What are those things? Arm group means the arm, okay, of the arm, which is it is actually a 7 degree of freedom arm. So it's different from the normal total board arm. Why it is 7 degree of freedom? Because it is more flexible and the success rate for the planning is better compared to the 5 degree of freedom total board arm. Okay, so it is designed a better version for the total board arm. Okay, so this one is the newer version of arm for Jupyter robot. Then the gripper group is just for the gripper, okay? And then you can see the head group is, you can see the RGBD sensor on top is actually mount on a 2 degree of freedom. I think it's a 2 degree of freedom pen tube, pen and yaw, right? Yeah, pen and tube. Okay, yeah. So it actually have another degree of freedom at the neck part. So if you want to turn the top camera, then you can use that. But we just look at the arm group first. Okay, go to the arm group. Okay, right. Okay, so then you can see the start state and go state. Okay, so now over here is the RVs, and behind there you can actually have the gazebo, right? So the gazebo represent the real robot. Is the physical model. The RVs is actually the planning interface. Okay, you need to understand these two are different. Gazebo is the physical model and the RVs is the planning. Okay, so you do the planning and once you execute, it will reflect in gazebo. You can zoom up the zoom in for the gazebo model.
Lag.
Okay, yeah, I understand. So Jupyter Sim is lag, I understand. So just take your time. Maybe IO will be better. Yeah, you need to run again. Is it okay? Oh, Professor Abu, you want to try it on your side using the IO?
Oh, see. Yeah, I will try to set up at the same
Yeah.
time.
Yeah, you try to set up and see is it work better at your side. I believe it work better. So that's why I said like the Jupyter Sim is good for you to try, but not good for you to do your project because yeah, it's very slow and it will always have this problem. But well, one is purely software and another one is hardware, so they are different.
Okay. Okay, yeah, I can already open.
Yep. So maybe like you can try to show us.
Okay. Uh, so can you see my screen?
Yep.
Okay. So now.
So you want to put like side by side the move it and also the gazebo. Yeah, you want to move it side by side.
Let's see the.
Yeah, this one you need to make it like smaller. Or you just drag to your left hand side.
Oh, okay, but yeah.
Yeah, you just drag to the left hand side and you just zoom in. Yes. Okay, good. I think that's okay. Or you can zoom. Yeah.
So now,
So what you need to do is you go to the arm group. You
mhm,
select the arm group.
arm group. Okay.
Okay. Arm group. Then your start position and your goal position. Your start can be the current one, and your goal position you select another one. For example, you can go to like catch. Catch, I think, is in front. Yeah. So this is catch. So you can do planning first to see if able to plan. Okay, so that is the planning. So the planning looks good, right? Okay, so if the planning looks good, you just execute. And you can see it update in the gazebo as well.
Okay. Yeah.
Yeah. So basically it's working, right? So
Yeah.
so what happened behind there is we already have the model, we have the URDF and all the definition, and then we have the IK, the IK and everything set up behind. So the IK will try to solve and give you the solution. And if the solution is working fine, without fail, then you can execute and it will send the control to the gazebo model and move the robot. And if you connect this to the real robot, you can see the real arm moving in real world. And of course, you can try with other combination, for example, like a different, and you can even use the drag the ball in front, the interactive marker to a different location if you want. Then you can do the planning, but of course don't too drastic because like the IK always fail if let's say you have very weird posture. Yeah, you can drag to other places and then you can try to plan, and if working give you an solution, then you can execute. So this will give you a full working example for the Jupiter Robot 7 degree of freedom arm using the MoveIt.
Okay. Yeah.
Yeah, it's working, right? And you can see it is much better on the I/O compared to Jupiter Sim, right? So that gives you the comparison between the performance lah. The I/O definitely will work much better than the Jupiter Sim. Okay, so I guess my sharing for today is almost at the end. So I would like to open for any question or discussion. Yeah, but before that, let me answer the door. Okay, right. So yep. So my content for today is almost finished. Let me check. Do you have anything left over? Yeah, no more. That's all. So that I want to explain today. So I would like to open. I have another 30 minutes. Yeah. So it's question and answer. So if you have anything you want to ask, yeah, feel free to ask me and we can do some discussion.
In the goal state, can we customize our goal?
Yep. Yes, you can create your own goal and save in there, but you need to open up the source code and have a look on the model. Okay, but if you don't want to specify, you can use the interactive marker to move your goal state.
On the Jupiter robot, there is a software called OpenVino. Is it can use on NVIDIA graphic card or only for Intel graphic card?
Okay. For OpenVino, if I'm not mistaken, it is not specific to Intel hardware unless you have certain example that it require the Intel hardware. Okay, but so far the example that we run, I think is universal. You can run in anywhere.
Oh,
But if I'm not mistaken, got certain example that it use Intel specific hardware for GPU or acceleration, and only those kind of example you require Intel hardware. The rest, if not specified, it should be able to run on anywhere. And if I'm not mistaken, our example should be universal to any hardware. Although the actual Jupyter robot is actually running on Intel.
is it possible to use the Jupyter's software such as OpenVINO for our own robot design?
Yes, of course. I mean, you see, you already have the Jupyter Sim. You can connect Jupyter Sim to any other robots. It's possible. But the thing is like you need to create the model, you need to modify you need to know what to modify. Okay, because it is designed based on the specification of Jupyter robot. But of course, things like for example, the vision system, it is actually quite universal that you can apply elsewhere. It is possible. But what we do is we design the example that we provide is specially designed with the specification from Jupyter robot. So it is working fine with Jupyter robot. But if you want it to work on other robot, other specification, you need to know how to modify.
Okay, thank you.
Yeah. Yep. Any more question?
Okay, Cor, Cor, do you have any question, Cor? Or you just open your camera?
So since today, I mean, like everything is running smoothly. For the I/O is running smoothly. For the Jupyter Sim is running smoothly. You all can access the courseware. So later on, we will put up the video and we can do some discussion there. Yeah, I think today we achieve all the objective we have set.
Yeah, and today we have mostly like Fahmi is still like first year student. I mean, so it's good that even first year student can also do this. So
Yep.
I think yeah.
Yeah,
It's very
because
good.
with the Sim and also I/O, I think everyone can start your ROS. Everyone can start your deep learning things and start to do programming. Because the system have eliminate a lot of very troublesome stuff for you. Yeah, I still remember the days that the first class is to tell the student to install Ubuntu 18.04. They don't even know what is terminal. Then they start to say like, so how to install, and then yeah, how to do the dual boot, and yeah, a lot of endless problem. Then after you install the Ubuntu, then the next thing is install ROS. Then got people install a different version of ROS. The ROS is not working, and so on. And that is the second stage. Then the next one is you want to install all the software framework. MyU, YOLO, OpenVINO, and all those things is not easy to install. Yeah, you can try yourself, and you know how troublesome is that. And now everything is working in front of you, without you need to do anything. Just install the VirtualBox and it works. Yeah. And for the I/O, the convenient part is like you can just plug in any PC, boot, do whatever thing that you want, unplug, and your system's still back to the normal one. So that's the beauty of this Jupyter system.
Yeah, and student can also focus more on the, AI rather than installation.
Yeah, because I think for engineering student, yes, there is some extent that you need to know, like for example, what happened to the driver, what happened to the port, USB port, and other things. But for computer science people or IT people, they don't even want to care all those things. right? They don't want to know all this, like what is the USB port that they use for the camera and so on. They don't want to know. They just want to know like how to do the algorithm. So they want something that is workable for them. So always we have all these technical issue that prevent people from focus on the development. And that's why Jupyter system try to eliminate all this problem to let the user focus on the things that they want to do. And I think this is very important for classes as well, because you have very limited time in your course, especially if let's say you want to do your assignment for navigation, then you start from the installation, then yeah, you will never end. Yeah, better you focus your time on how to improve the algorithm, how to design and start create your application. These are the things that I think you can focus. And once you have this thing working, you can dig down and slowly learn back all the basic. Like, so what is the actual thing happen? Because Jupyter system have given you all the source code down there. Okay, so you can actually open up everything and look deep down there later on to for more better customization. Because like as you go advanced in your project, you want better customization. Then you, for example, like I even have students start to think about how to improve the path planning and so on. Right. So then you need to open up the ROS navigation package and look what is inside, all the parameters, like how you define the size of the robots and so on, so that it can have a better turning, better object avoidance, and so on. So these are the things that we want the user to focus, rather than they get bogged down by all the installation, hardware problem, and so on. Yeah. So I hope like this system can really speed up and help you guys to focus on the robotics and AI development. Yep.
My question regarding this Jupyter Sim. So this Jupyter Sim is installed in a virtual box, right? So is it possible to install this Jupyter Sim as a boot, so we can dual boot it rather than install it like the
Okay.
virtual box?
I don't think the company will let you do that. Yeah, because they already make that into a product called Jupyter IO.
Because in the virtual box normally takes a lot of resources and it will lag our computer. So rather than using this virtual box, directly use the boot.
Yeah, we all understand that. That's why they have a product called Jupyter IO. Yeah, so that's the reason why they have the IO, is because we know if you can run the system on hardware, it will be better. Yeah, but of course, people that don't invest on IO, you can still try the system with the SIM. So that's the purpose. But of course, just now we already see like the SIM is not stable and it's dropped. So the Jupyter SIM is not designed for you to do your development. It's for you to try and learn. Yeah, but of course, if you want to like have a dual boot and so on, well, unless you install by yourself, which is the traditional way. Which is still possible actually, because everything is open source. Whatever that you see inside there, I think the only thing that is not fully open source is the Jupyter model or so on, but they also put the source code there, so you can actually access everything there. So not a big problem actually. Yep. Any more question? If how to say? If I'm not mistaken, they are coming out a cheaper version of IO for student. So that one maybe like if you really interested to get IO for study, maybe you can contact Jerry for more information later after this.
But that's on the personal basis, right?
Yeah. For the student personal basis.
Yeah.
Yeah, if I'm not mistaken, they have a cheaper version that's coming in production, because not just you, but many students actually come to ask me, say whether they can afford the IO. So currently the IO that UTHM bought, that one is for the professional class use. But for student level, they actually have another version which is catered for students. So that one, maybe you can contact Jerry for more information if you're really interested to have one.
Yeah.
Yeah. The price is actually much lower than the IO.
Yeah, may I know what is the expected price for the?
Okay, so that one maybe you contact Jerry
I
after
mean,
this.
that one is actually, we haven't launched it officially. So,
Yes.
but I say, so.
But I think that one very soon it will launch. Yeah.
Yeah. So, but because Abu told me that there's also another, there are also other faculties, lecturers, in this session now. So that's why, yeah, I just want to reiterate. So yes, the Jupyter IO is really, we hope that we can support the deployment of AI education formally in a classroom setting, right? So so that is to equip your future AI labs at UTHM, for example. So that will be something you want to do it professionally. But as you can see, there are many alternatives that were discussed today, whether you install the Jupyter Sim, that we gave this privilege to 5 accounts only due to the usage, right? But also, yeah, eventually in future, if you are a student, I mean, buying as a personal development, so that could be an option. So I think that's actually sums up the intention of today's session. Is we want to first tell you the AI robotics, what are the things. They are very vast, as you can see, cannot cover everything, but at least you know where to find information. But also we would like to introduce our products, from the robots to the IO. So Abu has bought from us the Jupyter IO, and then you have the and hopefully in a future product, they will in a future grant, we can also supply the Jupyter robot, right? So, but in any case, I think you got almost like 60% or 70% of the functionality or taste of the functionality through the Jupyter IO. So I would really encourage you to discuss internally, how can we scale this up, right? So how we can introduce this in your engineering course, or even you want to work together across faculties, reach out to your IT or computer science colleagues, that we can have some cross department classes, right, or joint classes in AI and service robot development. Yeah. So I say we again organize this quite short term or last minute basis, and Jeffrey is still actually in quarantine as well. But yeah, I think any other last questions that you can ask. But I think all the informations are there. So now you just need to take the time to read it through and to digest, which is very difficult to achieve that during the 2-hour session. So I can understand. So yeah, we hope that with that you can continue learning beyond this workshop, right? Okay. So any other questions? Are you good?
Yeah, any question? For example, like you want to learn it for your projects, you want to learn it for whatever things that you can feel free to share, and maybe we can give you some ideas. And my purpose is to show you in general what the Jupyter system can do, but there are actually a lot more that you can think of. Like if we can combine the speech with the vision with the navigation together, and you can have very complicated application development actually.
Okay. So
Yep. Your question, Zubai? I thought I heard his voice, Zubai. No, okay. So yeah, because I think this guy they already tried to do a lot of programming for the past 1 month. They should have a lot of questions, but today I think
I don't know what to ask. Okay, never mind. We still have the platform for you to ask. Later on, you can post it in the forum.
Okay, especially for the 5 account holders, please make use of the Jupyter Sim. Because really we can't afford to give it to everyone, so unfortunately, but at least 5 I think is what we fight for UTHM, and then you can compare, right? So using hardware and without the hardware, so that's the trade-off, right? So of course the best is with hardware, but we also recognize the reality of budget constraints and everything. So that's why you need to put up with some inconvenience if the hardware is not available. But at least you have 1 unit of the Jupyter IO, right? So maybe Abu, you would like to, you can see how you can have other students to try it as well, especially those that are using Sim now, that he can also compare later how easy is this to just plug into a USB connection, and then you can have everything already set up, right, without any software installation. I think this is the plus point that you only will experience it when you do it yourself and you see the vast difference, right, compared with the steps that you need to go through to download the Sims. Okay. So if there's no other questions, I think we may very well close this session. So I say the forum is there for you to ask any questions, or post any videos or any source code or any programs that you have done. Just make use of that. Okay. All right. So if there's no more question, I suggest we are like about 10 minutes ahead of the schedule, but it's not too bad.
Can we have a group photo?
Yes, sure.
Yes, everyone, please turn on your camera. We at least have a group photo before we end the session.
Yeah, so that we can also do some promotion that we also learning during this pandemic time, right? Okay. All right. 1, 2, 3. Okay. All right. Okay. So that's about this, right? So
thanks a lot.
Thanks everyone. Thanks Jeffrey. And let's stay in touch. I'm very much looking forward to hear what comes up after this, right? So you got the introduction now, you got the hardware or the software, and then make use of it. Okay. And with that, stay healthy and have a good week ahead. Yeah. Thank you.
Thank you. See you.
Bye bye.
Thank you.
Thank you. Bye bye.